Jai Jinendra, Namaste, welcome to my channel. Today I am going to solve the 13th question of the problem solving series that is based on arrays. So let's begin. Find the duplicates in an array where the elements are from 0 to n minus 1. The values are from 0 to n minus 1. Let's look at the example. This question has been asked in Paytm, Amazon, Flipkart, D-Show and many other companies. The difficulty level for this question is medium. So let's see the example. So we have this array where the number of elements are 7 and we can see there are duplicate elements in the array. So we need to find these duplicate elements and return them. We will be returning it in the form of vector. I am coding this question in C++. So here as you can see the element 3 has come twice, 1 has come twice and 6 has also been repeated. So what would be the answer of this question? We will be returning 1, 3 and 6. These are the three elements that has been repeated. Also I wanted to highlight that the numbers are from 0 to n minus 1. That means if there are 7 number of elements, the value of the elements in the array can be maximum from 0 to 6. It won't extend. Otherwise, there is a chance of not repeating. But if there are 7 number of elements and we can only store up to 0 to 6, there must be one element which has been repeated. That's why it's mentioned that the elements are from 0 to n minus 1 and there are n number of elements. So here, there are 5 elements and we can only store 1, 2, 3 and 4. So what element has been repeated? We can see 3 has been repeated. So we will be returning 3. So how do we solve this question? What is the approach? Any ideas? What is the intuition? We can see that we know about hashing, right? We have solved questions on hashing. So to find out whether a number is repeated or not, we can count the frequency. How do we count the frequency? We can store all the elements in a map or a set. And then if the element is repeated, we can see it from it whether it is repeated or not. We can use the find function or any function and that we can check in order of 1 in the map. And suppose we traverse this array, we store 1, we store 2, we store 3. We keep on checking whether that element is present in the map or not. If it is not present, we store it. And then when we store 3, again we see that 3 is already present in the map. Then what do? We will store that 3 in our vector. Similarly, we will go to 6 and we will see, okay, 6 is also present in the map. We will store 6 also in our vector, and when we go to the last element of the array, we see 1 is present in the map. So we will store 6, 3 and 1 and we will return that vector. Same we can do for this example and we can solve our question easily. What would be the time complexity? We are traversing the array once only, so the time complexity would be order of n. But what would be the space complexity? We are using the map. We are storing the elements. So if we are storing the elements, it could be that we will be storing maybe n minus 1 number of elements. So the space complexity with the hashing approach will also be order of n. So with hashing, we can solve it in order of n time complexity and the space complexity will also be order of n. So, can we optimize it? Is there any way that we can reduce the space complexity? We can't reduce the time complexity because this is an array, we have to traverse it. So the time complexity will always be, can't be lesser than order of n. But can we reduce the space complexity? How do we reduce the space complexity? We are storing the elements. Without storing them, is there any way we can we solve this in order of 1 space without using any extra map or set, anything? Is there any way? Yes, there is a way. What we can do, we can play with the index of the array and we can store the elements index. Inside the index of the element, we can store the element. So what will happen? When we store that, since the elements are repeated, for example, this 3 has come twice. So if I store the value like this, plus n. What will happen? When this 3, the third element will A3, right? A3 will be coming whenever I will be storing. I will be traversing this 0, 1, 2. So when 2 will come, so A of 2 is 3. So A3 will be coming twice and it would be getting added and A3 plus n will come. Again when I will go to 4, so 4 is A of A4, that is A3. So again A3 will be coming and will be adding A3 plus n, right? So what will we do? We will do is whatever the value is there, we will be adding the same values, previous value, or same thing, right? We can do the same thing because it will be added again. So already the value of A3 would have increased in the first time, the n plus A3. So that means 3 plus 7, not 3, whatever the value is there. So A of A3 will be added, increase the value by n, and then when it will be repeated again in the fourth index, again it will be increased. That means it has been repeated. So n plus whatever the value it was there. But that will not happen for first index A, 1, 2 or those elements whose index has not been repeated. So when we will traverse the array again, then we can see if the values of the elements in the array, if its value is greater than double of n, that means that the element has come twice already, and we will store those elements whose values is more than 2 of n. Right? You get the intuition. Let's write the code for it, and then we will try run it for this this example. Okay. So what I mean to say, that we will have a vector of, let's say, answer, we declare it, then we traverse the elements from 0 to n minus 1, and what we do, we store this value, increase it by n, and when it will be increased, it will be increased twice over here since it would be coming 2 times. So when you traverse this array again for I equal to 0 to n minus 1, and if A of array of I is greater than 2 into n, that would mean that the element has come twice, and we will store the index, because that index has actually come twice. This 3 has actually come twice, and we are storing the index now. So in this way, we will be returning this array of answer, and this answer will contain the duplicate elements in the array. I think this is clear, but we will try run this. This approach solves it in order of n, and the space is also order of, not n, order of 1. Right? Let's try run this example for this code. Okay. So okay, let's try run it over here for better understanding. What is the example? 1, 2, 3, 4, 3, right? N is equal to 5. Okay. Now we are traversing this A of 0. That is A of 0 is equal to A of 0 plus 5. That means A of 0 is 1. A of 1 is A of 1 plus 5. What is A of 1? A of 1 is 0, 1, 2, 3, 4. A of 1 is 2. 2 plus 5 is 7. That means A of 1 has become 7 now. Right? So this is our new array. 2, 3, 4. Okay, 0, 1, 2, 3, 4. So what is the value of A1? A1 is 7 now. Right? Now we will go for the first index, that is A2. What is A of A2? A of A2 is 3. So we'll directly write 3 over here. What is A of 3? A of 3 is A of 3 is 0, 1, 2, 3, 4. 4 plus 5, that is 9, right? So A of 3 is 0, 1, 2, 3, this becomes 9. Earlier it was 4, now it has become 9. Now 0, 1, 2, what is 2? A of 3, what is A of 3? 0, 1, 2, 3, that means 4, right? Right. What is 4? A of 4 is A of 4 plus 5. What is A of 4? 3. 3 plus 5 is 8. So this becomes 8. Right? Now we have done 0, 1, 2. Now we go to 0, 1, 3. What is A of 3? A of 3 is we went to 0, 0, 1, 2, 3, 3, 4, right? And now 4. 4 is 3. Okay, 0, 1, 2, 3, 4. 4 is 3. So this becomes 3. A of 3 is equal to A of 3. That means 4. 4 plus 5 is 9. No. What is A of 3 now? We shouldn't take this A of 3 value. We should take the new A of 3's value. That is 9. We can't take these values. These values have changed now. This has become 7. This has become 9. And this has become 8. So when we went to A of 3 again, since it is repeated, so we will be taking the value, current value, that is 9. That means 9 plus 5, that is 14. So this value would become 14 now. Right? And we have traversed all the array. So the other values have not changed. They are same. 1, 3. The value for this element is only greater than 10. So that's why we will store the index. What is the index? 3. So here 3 will come and this vector will have this third element, and that is the index and that is the value here. So in this way we will solve this question. I hope you have understood this question. The link to the question has been given in the description. Please try it yourself, and then let's go to the code walkthrough section.
So here is the code walkthrough section of the 13th question. Find duplicates in an array. So here if we don't find any duplicate, it's given that we will add -1 to the vector and we'll return it. Otherwise we'll return the duplicate elements in the vector. So as we know that we have discussed the solutions already in the discussions. So we have used this formula. We are adding plus n, and whenever the element would be duplicated, like for this example, in this example 2 is duplicated, so the index, this 2 would come twice, and the value of the element would become double of n every time, because plus n it would be coming twice. We are playing with the index over here, and then we'll be when we'll traverse it again with in the modified array, we'll be able to get the duplicate elements and add it into our vector. And if we find that after this there is no duplicate elements, then we know that the size of the answer will be 0. So we'll add -1 over it to it, and then we'll return this answer. Let's compile and run it. So it's working fine for the first example, and so let's submit this. So we can see all the test cases have been passed. Let me know how was the explanation in the questions. The time complexity and space complexity, as already discussed, are order of n, order of 1 respectively. Let me know in the comment section how was the explanation. Is there any doubts? and we'll see you in the next video where I'll be explaining the 14th question of the problem solving series. Thank you.